Like, okay.
Level, I mean, just like this is where the entrance, etc.
Uh, yeah. Okay. So you guys are familiar with the package structure, I think. So storage app is essentially where we have all we have is our HK2 binder and like the main class, which starts a server, which is our Fourier REST server here, and then let's see, the like the client-facing like entry point will be where is it? So these resource controllers here. Um, yeah. So this is
Hey,
these
sorry.
are hey
Sorry guys,
hey
I've
Oshul.
just joined. Yep.
Hey Oshul. Yeah. So we're going into I guess um, a bit of like a code walkthrough of what we have in Fourier or storage Fourier
Yep.
for the Hitachi developers.
So just one question. Who are the Hitachi developers? Is that Sagreen?
No,
Sorry if
no,
I
no. It's Girish and Hemant.
Okay, they're on the call?
Yeah, they are.
Yeah.
Okay. And one other question, sorry. What are we trying to achieve? Like, are you guys going to be developing code in this code base?
Yes.
Yep. I think the idea is that we'd like them to work on migrations for Hitachi.
Right.
Yeah, since
So
it
we're
seems like
kind of trying to understand what has been built and how your flow of information is inside the code.
Okay.
yep.
Okay, fine. Sorry, Jason, carry on, yeah.
No, it's okay. Right. So in this, these are the REST resources that we expose to clients. So this is like the entry point into Fourier is these resource controllers here. The idea is each one of these will have an associated service of some kind defined in storage core. Since most of these requests are not going to be appliance or vendor specific, they're going to be in storage. Here we have like the concept of orderables, which is like a type of storage that you can order, and then those can route to different vendors and different appliances types. So the idea is in core, there's going to be some generic orderable level services defined that these resource controllers will invoke. And then in those orderable services, those will have, there'll be interfaces that will be implemented at a appliance or vendor specific level. So here you see we have storage core, this package. There's interfaces in here that are implemented in storage Hitachi here. So right now we have we have a new provisioning scenario implemented currently for a Hitachi VLDB use case. I don't know, should I go into I guess I can go into the code for that if that would be helpful. Also feel free to stop me anytime. I don't,
You guys developed REST APIs before? Do these annotations, for example, make sense? Host produces, consumes, API operations.
Are you asking Girish and Hemant?
Yes, yes, sorry, yes.
Yes, absolutely.
Okay. Right, so these are just standard like Jersey resources.
What do you mean Jersey resources? Like for New Jersey?
No, like that's the I guess like the
So Jersey's like the
it's like a library, I guess, a standard
okay, all right.
like resource REST library
yeah,
for
if you've heard of Jax, if
Yeah,
you've heard
yeah,
of Jack's RS,
yeah.
Sabine, we
Jersey
are
is
not able to
the,
hear.
Oh, you're not able to hear? We're not able to hear sometimes as well. Okay.
the Jersey is the reference implementation for Jack's RS, which is the Java REST API or REST Web Services specification.
Okay.
Yeah, and out of the box, it uses a web server called Grizzly. So Grizzly is the web server, and Jersey is the reference implementation of Jack's RS.
Okay.
Okay.
Sabine, we missed most of the conversation, so can somebody recap for the last couple of minutes?
Yeah.
And I have a question on which Tomcat. I mean, is this being deployed on a Tomcat, or is there a different server?
We're deploying on a Grizzly server. There's some, there's like a internal library on top of that, but the base server is it's a Grizzly server.
Okay.
Yep.
Okay.
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 Um,
So what is this that we are seeing now? Is this the controller code?
yeah. So these are these are the REST resources that that we expose to the client.
Okay.
Yeah. So this is for our VLDB provisioning use case, which is the only thing that we've really implemented so far.
Okay.
Yeah. So I don't know how much you heard, but essentially from each of our our like REST controllers, right? We invoke like core service interfaces, right? And then those interfaces are going to be implemented on a vendor-specific, like there's vendor implementations for each of those interfaces,
Okay.
and that's how we are sort of delegating the
Okay.
provisioning and other tasks, right, in our code. So
Okay.
I was going to walk through our VLDB use case, but I mean, I think that's going to take a while, and I feel like that's not going to be all that useful. I don't know if anyone has other ideas of what you'd like to see, or like I don't know. I could just
Maybe
walk
just
through
a
this.
sample class to show them what the kind of, I guess, testing you were going to mention that.
Yeah, I
I mean,
was actually gonna.
yeah.
Yeah.
I think it's
Go
worth
ahead.
looking at a couple of things. It's worth looking at fitness. It's worth sort of having a look at some of our JUnits. I think
Yeah.
it's also worth looking at the command logger and command chain classes.
Sure.
I would say those. I mean, I would say fitness, and then command chain, command logger, and then after that JUnit.
Yeah. Sure.
Yeah.
Yeah. Okay. So right. So fitness is which Hoshul just mentioned. Fitness is our scenario testing framework. So sort of at a higher level than Girish, you were asking how we test without having an actual appliance to test on, right? So fitness is how we do scenario testing, which the way I describe it is it's a level up from unit testing, where it tests like your application internally is behaving as you expect and not specific components of your application. So it tests that your entire application works. So it's sort of like an integration test, but not really, because it's not tested against other live services. I'm going to run, oh man, I think it might just be, I'll just show you. So,
has anyone used fitness before? Is that something that you guys have experience with?
Girish, you there? Hello?
Not there?
Mm.
Yeah, I'm still here. I'm just seeing it. Girish looks like he's
Yeah.
on the meeting, but I can't hear him.
We should wait for him, right? Because he's the main guy on this, I guess.
Yeah, he is.
Yeah.
Okay. All right. I just said, can you? He says he can see. Can you hear us? He's saying no. It's going in and out. Okay. I'll translate it. I'll translate it.
Can we? Well, no. Can we maybe catch up later or tomorrow?
To do this?
Because obviously, if you're going to be either later today or tomorrow, because obviously if you're going to be typing everything out, he's going to miss things, right?
Yeah, no, but I'm also recording our audio, so audio and the screen,
Okay.
so I can give it to him after the call, and then he'll be able to go through that, and if there was any questions, he'll just send us a question, hopefully.
Okay. All right, Jason, you're being recorded.
Yeah, I know. It's a bummer.
So it's so Jason, if you say something wrong, it's gonna be, oh no, but Jason
I know.
did that.
Gonna be, yeah. Now it's audited.
Yeah.
And I'm accountable. All right. I should speak more professionally. Okay. So, right. So, oh man, sorry. Okay. So this is fitness, which is how we do scenario testing, right? And what that means is each of these defines essentially a client use case for the application, right? So here we have where is it? Provision. Yeah, so a VLDB provision, right? So from a client perspective, this is just a single new provision by a client for VLDB provision for VLDB storage on a Hitachi device. Okay. And what this does, you can see there's various like tables here with inputs and expected results here, right? What this does is this is testing. This will execute a request. It'll send a request to Fourier. Fourier will execute the entire request, top to bottom, and then return with something. And here you can see we're asserting that the response we get is what we expect it to, the response we get is what we expect it to be. We're asserting that there's been changes in the database after this successful provision. Right, we also check that requests were made to the appliance, and these are the requests that we expect to see come into the appliance. And so you were asking, or Girish was asking how we're able to test this stuff without an actual appliance being ready. And so these tests here, these fitness tests, don't go to a real Hitachi appliance. Instead, what we do is when we start this test, so here you can see these are like the startup things for this test. Like this is the setup, the test setup. What you can see is we start up a Fourier service. So here we are, we're starting up the actual, the actual Fourier server, which runs the actual Fourier code. But here we also start up a test Hitachi appliance. And all this is it's another REST server that we've written, and it implements all of the same endpoints that the actual Hitachi REST server implements, but obviously without the actual like appliance level implementation, right? All we really do is we keep track of which requests came in and in what order and things like that. So that's what I mean when I said this wasn't like a real integration test, because we're not testing against an actual appliance. We're testing against what we believe the appliance essentially to look like, and how it like the interface of the appliance, but not the actual appliance.
Got it.
So this lets us do things. Yeah.
So as of right now, are we not testing it, or we don't do anything against the appliance, or everything has been done only in fitness, or certain parts have been, built which talk to the HDS real
No,
appliance?
we do testing. We do testing against a real Hitachi array, right? But what this allows us to do is to every single person working on this can actually run a suite of tests without actually having a physical array to be speaking to.
Right. So have we gone beyond this level to talk to an actual HDS array already for certain things?
Yeah, we have.
Okay.
Yep. So those are all manual tests being running now. In terms of automated tests, right? This is how we do it for storage Fourier.
So if you think about it, go ahead, Jason. Sorry.
Okay. Well, what I was going to say is we run these as part of like automated builds and things like that, right? And these run on a schedule. So these fitness tests we run as part of our build, and we don't want our build to be dependent on like the availability of an appliance or the availability of some other service that we don't control being up or down. So this lets us test like the internal workings of the entire appliance without being locked into dependencies like that.
Mm-hmm. Got it.
But of course, for like when we do releases and things like that, we will be testing against a real appliance. But this is mostly for like pre-commit builds and things like that, making sure that you haven't broken anything internally.
Got it.
Hosh, I don't know if there was anything you wanted to add.
Yeah, no, I think that's it. And I guess as a scenario, right, what would happen is imagine if someone changed some code which resulted in one of these REST endpoints no longer being called, then we could find out immediately, not when we executed against a real array. So this does give us a massive amount of confidence that things are going to be okay. And then as Jason said, the final sort of stages, we would actually test against a real array as well.
And just to know, when you moved this when you tested against the fitness and then you took that and put it against the real HDS, did you guys find any problems with that, or for most parts it just kind of worked as expected? Like did the HDH device actually throw up some weird stuff, and it was like, oh, we couldn't take care of that in fitness, so it came to discovery only after you actually implemented it against a real array?
I believe it mostly worked as expected, but Eliza would probably know best. She did most of the testing against
there was one thing when the IQN was not capitalized and Hitachi, it was capitalized and Hitachi expected lowercase, but besides that, it's been working as expected.
Okay, all right. So that's really good. If that was their biggest problem, that's pretty good. So okay, Girish had one question. He was asking what interfaces need to be implemented currently for the HDS.
Sure. So right now the only real end-to-end use case that we've done is the new provisioning for this VLDB use case. We still need to do we need to do increase, decommission, and migrations. So our four main things that we want done is provision, which we've done, right? Increase, decom, and migrations.
What does migration mean? Like going from moving?
Sure, from moving actual data from devices on an appliance to a different appliance.
Okay, are you moving data or are you moving like entire like LUNs or something? You know, or what you call as I think mobility unit.
Yeah, so moving entire mobility units from one appliance to a different appliance, but that will include, right, like copying the data over, creating the expected constructs on the target array side, right? It's going to have to include a lot of things like that.
One of the scenarios would be, if we have a workload on an array, and that array is being decommissioned, then you'd need to migrate that workload onto a new array, right? So that's one use case for why you would do a migration.
Mm-hmm.
Another use case might be that you've got a workload which is actually causing a lot of load on an array, and maybe that workload needs to be isolated or moved to another array, and therefore you would migrate that workload from one array to another. So these are just a couple of examples of when we would do a migration.
Okay, and then the associated things which should happen when that happens, right? So you got to change the the values in the database somewhere, saying that now this mobility unit now exists on a different array. We have released the space on the old array, but we have increased the space on another array. All that has to happen, right? Not
Yep.
just as simple as migrate, and because if I remember correctly, with this new model, all the writing to the database is actually happening within the interface versus in the old way, where the task was completed and then passed back to the upper layer, which would then do the writing to the database. Correct?
Yeah, that's correct. So it'll happen as part of the like the implementation of the migrate. You would have to do essentially all of those tasks, right? You would have to essentially do a new provision on the target array, do something to, and that includes updating the capacity and things like that on the target array inventory that we have internally. Then you have to copy data, and then you would have to decommission the source, and that would include another like database update, right, of releasing capacity back in our inventory, and that would have to all be part of the migration like implementation.
Would that
now specifically which interfaces need to be done? That will depend on how you guys, or like how we decide to implement migration, right? Like specifically what interfaces, that'll depend on how we decide to go about doing this.
Okay, so another question which I can think of is like, are most of these implementations are they atomic in nature, so that either it happens in its entirety or it doesn't happen at all, so we kind of roll back, or
sure. So that's a little separate from the interface thing. Essentially, we want each one of these use cases to be from the client perspective, at least. We want it to be atomic for them, right? So either it happens or it doesn't happen, and if it doesn't happen, they can send the request again, and either this time it'll happen or it won't happen.
So
but it won't be like in a halfway state, right?
Okay, so like for example, in terms of like a decommission or a migration, so we were able to do, like for example, in a migration, or we were able to do the 3 steps, and we got stuck on the second step. So then that would mean we would need to roll back the first 2 steps and then come back and say, hey, we failed, that migration failed, right? Okay.
Yeah. So right, each one of these tasks could, like on the back end, right, they could be n number of like non-atomic actions, right? Like it could be n number of things that may fail. But we've implemented a mechanism where if any of those n steps fail, it'll roll back, everything that has already been done. So to the user just has the one action where they say, migrate me, right? And to them, it looks like it's just one thing that's happening. But what we want to implement it in a way on our end where any number of steps may need to be done to do this one thing, and we need to be able to roll back all of those actions if necessary.
On a high level, do we have those n steps for doing a certain action, or are we still planning it, or is he leaving it to us to come up with the n steps?
So for the migration use case, right?
Which is the
I think,
hardest one, not hardest one, but has the most steps.
Yeah, yeah, that's more or less true, because increase and decommission are once we've done provisioning and like the associated rollbacks, right? Increase and decommission are I don't want to say trivial, but they're pretty straightforward to implement with what we already have now. Migration is going to take a bit more work, and I think
just to interrupt you there for a second, with the decommission, is it a combination of a migration plus decommission? Because if you're just decommissioning, don't you need to move whatever's on that unit to somewhere else before you decommission it? So wouldn't that involve?
Not necessarily.
Okay.
In some cases, if no one's using a certain database or something, we could just decommission the whole thing and free up the space without having to move it. They're not necessarily like, they don't necessarily both have to happen.
Okay.
Right, but yeah, migration is going to need a bit more time to figure out. And I think I was talking to Mike, and the way migrations have to be done for HDS devices in general is a little different than how we thought it was going to be. So I think having you guys help us with that, since you guys have access to like the Hitachi SMEs and things like that, might you guys might have a better chance of getting it right, but we have only, I think, a very high level overview of what needs to happen for migrations, and I think we would need to sit down later and hash out exactly what needs to happen for migrations.
Mm-hmm.
Yeah, but I mean, high level, right, is more or less what I've said, is we have to, provision on the target, copy data, and then decommission from the source. Obviously, it's going to be more than just those three steps, right? But
right, yeah. Because you got to update the database also appropriately for the arrays which have been affected by this migration. So,
yeah.
Okay. Okay. All right. So primarily it's increase, decrease, decom, and migration. Those are the four interfaces right now that we have on the plate.
Yeah, not decrease. Just provision. So like I guess add, increase, decommission, and migrate.
Okay.
Decrease, to be honest, I don't know if we're gonna do this.
Okay.
It's a very, very rare operation, so it's probably something that we would skip.
Yeah. Nobody wants less, or everybody wants more.
That's it. Yeah, that's true too. Yeah. Yeah. Right. Okay. So that more or less covers our scenario testing. Okay. And I guess I'll briefly cover JUnit tests. Since while we're on the topic of testing, so we're a fairly test-driven team. Essentially, every class that you implement has to have an associated like unit test with, and the unit testing framework we're using is JUnit. So if you see here, this permit role membership provider class, right? This class has an associated, JUnit test for this, and this is going to be the case for pretty much every class that we've implemented. So we would just expect the same the same type of testing behavior, I guess, from the Hitachi developers.
Yeah, I mean, what I would say is that maybe it's worth looking at Sonar, but we have something like 98% plus unit test coverage. And in addition, we use a tool called PyTest.
Oh no.
If you go dashboards.
Oh, do I? Okay.
TI projects.
This guy?
Third item, yep. Yep, and then we should have a...
Yeah, there we go. Yeah.
There
So we're at
99.5% unit test coverage, and then we have 76.3% mutation coverage as well, which we do need to improve on, but just something to consider.
Yep.
And actually what happens is the build will break if you check in code which doesn't meet 99% coverage.
Got it.
Yeah. So yeah.
Yeah.
Yeah. So actually, yeah, you have to test it, otherwise the build will break.
Okay.
Yep. Yeah. So yeah, that was just pretty much all I wanted to go over for JUnit tests. And
So
I
if
guess
you
the
wanted,
third,
oh, sorry, finish your thought and then I'll
no,
answer the question.
no, go for it. I was gonna move onto a different topic.
So from a process perspective, in terms of testing and all that, so the person checks out the code, does the work on it. If it's fresh, he'll start fresh. Once it's done with that stuff, you have the JUnit testing, which it takes precedence. After that, you have the fitness testing before it gets deployed. I'm just trying to understand that hierarchy.
Actually, what I would say is if you go back to the fitness page, and if you go to the root page, okay, actually go back to the page that you're at. So these are our tests for VLDB. I would say we should start here. And effectively, right, if you look at the VLDB pending test, which is a section that's struck out, right, you should start with documenting all of the test scenarios that you want to develop, right? So before you do any development, right, let's figure out what are the scenarios that we want to test, okay? And then we can commit that fitness test in, okay? And then we can start developing. And when you develop, right, you need to obviously write the code and write the associated unit tests and write the fitness tests.
Got it.
Yeah. Keep in mind the fitness test is it's sort of end to end, right? So you might not be able to have or I don't know, Hoshul, would you say, like, I would say wait until most of the implementation is done, right? Like,
true. I mean, at a minimum, we should document the test. So we could say, like, migration from iSCSI to iSCSI for VLDB Hitachi, right? And you've got that here. Actually, there's a simple migration for that. And maybe there are some other scenarios, and maybe you want to document some. You can see here if you click on that, there's actually nothing there, right? And that's because this still needs to be populated, right? So yeah, so start with just at a high level documenting what we want to test. And then write code alongside when you're writing your code, write your unit tests, and then towards the end, when you can piece everything together, then you can complete your fitness test and commit that.
Got it.
Yeah, but it's very. I mean, look, we start with the fitness test, right? By starting with documenting what we want to test. So from that perspective, it is test driven. And then obviously every bit of commit needs to be associated with some testing, because if you don't accompany your code with tests, then the build's going to break.
Got it.
Yeah.
No matter how small or big.
Exactly. No matter how big or small, you just always have to write tests as you commit your code.
Got it.
Yeah.
Yep. Right. Okay. So that's testing, and I think the last thing that we were talking about was going over how we manage transactionality in storage Fourier.
Mm-hmm.
Okay. So in Fourier we have this interface, a command, a command interface, right? And what this is meant to represent is a single atomic unit of work with an associated, some execution of this bit of work, and then some way to roll that change back. Okay, so each command is meant to be like one atomic piece of work. And so I mentioned previously how like each one of those, like say for a provision, it's going to be like 10, 15 like little atomic units of work, right? So each one of those bits of work is going to have an associated command, and then we chain all of these commands. Whoops. Oh God, why? Command chain, is that it? Yeah. What we do is we execute n number of those commands in a command chain, okay? And then we execute those commands in like one chain execution. And what we've done in the implementation of this command chain is we'll execute all of those commands. If any single one of them fails, we will revert everything that has already been executed. So we'll invoke that revert method on the command interface. And
So,
yeah.
oh, sorry, finish off, Jason. Sorry, I thought you'd finished.
No, that was more or less it. I was taking up space with that word.
Okay, so what I would say is, yeah, everything Jason said, but if you look at this, right, you have two things. You have transactions, which is your list of things to execute as part of a sequence of events. So if a migration requires, step number 1, do a provision, step number 2, move data, step number 3, associate, step number 4, deassociate, that might be 4 commands, right? So you have to implement the command interface. And then as those steps get executed, they get added to the executed transactions stack. And if at any point something fails, then essentially we roll back by popping things off the stack and calling rollback on each one, or calling revert on each one.
Mm-hmm.
Yep. Mm-hmm.
And then all that information is logged somewhere, so you can go and try and see what failed, kind of, right?
Yeah, there's a concept of a command logger, so everything is logged as well, which is effectively your transaction log to some extent. But I guess the most important point is that every command you must be able to execute, but you must be able to roll back and take back to the state that you were previously in.
Mm-hmm.
Right. So as Jason said, right, you've got the concept of an execute, and then in case something in your command chain fails, then you need to be able to revert back, which takes you back to the state pre-execution.
Got it.
Okay.
Okay. Girish had Girish had one question here. Is there any, none of this in this new Fourier has any kind of rest in it, right? So there is no more rest. Internally, there is no rest. It's things talking to Fourier is via rest, and the implementation of the, like, what do you call that? A commission, decommission to the array could be rest, but internally there is no rest between.
No, everything is in a single process.
In a single,
right?
Yeah.
So everything runs within a single JVM, sorry. And then the command itself can call out to the database, or the commands can call out to a REST API or something else, right? But within Fourier itself, there is no other external activity that's happening.
Writing to the database, is it like a direct call to the database, or is there
It's
something?
using Hibernate.
Okay. Got it.
Yeah. Actually, guys, I've got another call, but so I'm going to have to drop off. But
yeah, but this
yeah.
was good information,
Okay.
Oshel and Jason. I think you got to drop off at 11 too, right?
Yeah, I got to join that same call.
Oh, okay. All right.
Okay.
I will go back and digest all this, and if there is any questions, I'll definitely send it back to you guys.
Sure.
Okay. Thank you.
All right. Thanks, guys.
Sounds good.
Thank you very
Thank
much.
you.
Okay. Bye.
Bye.